Sup guys, welcome to today's show. I'm sorry for not having published any video for quite a while, but I've been having some health issues. I had a leg wound which broke off and put some blood clot in my lung and stuff. But now I'm feeling better. So today we're going to focus on advanced NAS and macros. So the goal of today is to create something like, let's say we are coding assembly and creating a big project. So we want to be or stay organized, right? So we have some assembly. Maybe we move into some register, some value and stuff like that. But then I want to have like an if statement. Because as you know, there are no real if statements inside of assembly. There's just conditional jumps. And if you don't know what that means, I'm going to show you that as well. But let's say we have something like this. So if equal AX5, let's say, then we have some other code here. Let's say we move into some other register, some value, and cause an interrupt or something. And then I want to have an else statement. So let's say we move another value in this case and issue some other interrupt. So something like this I want to be able to put inside of my assembly code. And why would I want to do that? Because when coding a big project, you are going to have to face some part when you're going to have some advanced if statements. And if we want to translate this, by the way, maybe it's better to start and at that end, because in assembly, you usually do it like this. So first we compare AX to 5, and then we do a conditional jump. So since we want to check if 5 is equal to AX, what we usually do is we do a not equal. So we jump if not equal to some label, let's call it no equal, which we have down here. And down here we will put the else clause. So we move this and do this. And then we jump to some end label, right? And if it is equal, then we just want to put that code right here, because then we won't do the jump, right? So it's going to be something like this, and then we jump to the same end label, which we have down here. And as you can see, this is pretty simple inside of assembly. So why do we need a macro construction like this? Well, the trouble is when we are dealing with nested if statements. So maybe we have this stuff, but we also want to have another if statement. So if not equal cx0, let's say, then we want to have some other code here, if then. So the trouble is when we are jumping like this, we need to create a block of its own for each no equal statement and for each equal statement. And we need to name them, and it becomes very complicated when we have nested stuff. And even if we have another layer of nesting, it will be even worse. So that is why I want to create this thing. So in big assembly projects like my 16-bit OS kernel that I'm building, 100% assembly, at least the inner parts of the kernel, there I really need something like this. And I would also like to have something like a do while. So let's say we have while minus minus cx do, and some code, done. This would be pretty cool too. So it will interpret this string and minus the cx and then compare it to 0 and abort the loop in case of that stuff. So this would also be very useful for the same reason, especially when we combine while loops and if statements. So if we have time, I want to try to do this as well. And maybe we do it in another episode, we'll see. But let's start with the if stuff. So we are going to create an if.asm. And let's do it in 16 bits assembly, it doesn't really matter. So down here, let's use the stuff. So let's say we use pretty much what we did before. Let's compare. Maybe we can start with something like this. So let's say we have if statement, compare, let's say e for equal, and then we compare ax to 5. So when we have this kind of stuff, then we can create a very simple macro which turns this into if equal, for instance, ax5. And then it will just add this. So this will be the inner part of the code, so to speak. And then we will have some additional layer of macros making it easier for us. Because I also want to have stuff like if test, bx, let's say 2 or something. And this should be if statement 0 test bx2, right? So if we have this general construction, we can easily create these other ones, and these will be the ones that we use in our code. So we want to create something which has this, and then move bx5 int 10 else. Let's wait with else, I think. Yeah, let's start simple. Let's just have the if for now. So we want to have this code down at the bottom of our file. And up here, we want to create the macros making this stuff work. So the idea here is I'm going to start very simple, which will not allow nesting and stuff like that. And then we're going to improve the macro step by step. Alright, so the syntax is going to be if statement, condition, and condition is either E or not E, and stuff like that. And then we have an instruction, so like the compare or the test. And we translate this by doing macro, if statement, and then we provide how many arguments we're going to have. So we're going to have one for the condition, and then the rest we want to group together into the instruction. So we can do 2 plus. That's what it will do. So %1 is going to be the condition, %2 is going to be the rest of the line, the instruction. Okay, so what do we want to do at this if statement for now? Well, we want to we just want to run the instruction at this point. So we take %2 and macro. So that's the whole if statement as of now. The actual work will be inside of the then, because that will be a macro on its own. But maybe we shouldn't call it then. It might collide with something. Let's call it if then. Not very handsome, but maybe we can figure out something other later. So we're going to have a if then. And this is not going to take any arguments. But what about the condition? How will this remember the condition? With this simple construction, we cannot really do that. We will, however, when we improve this macro. But for now, let's move this equal as an argument to the then. I don't like this if then. Let's say, let's do a then underscore, even though I hate underscores, but we can change it later. Okay, so we need to change this signature, and this is going to be 1 plus instead now. And this is going to have then condition. So it's going to take 1 argument. Alright? So what do we want to do? We want to, let's see. So at this point, we have done the compare, because that's this %1 thing here. So now we want to make a jump if it's not equal. So the opposite of %1 here. So we want to jump, and how do we add them together? I think is it %+, and then or maybe we just do like this. Okay, so what we can do is like this, but in this case it's going to jump if it's equal, and we want to jump if it's not equal. But we can improve that later. So let's reverse it for now. We're not having an else clause anyway. So if it's equal, let's say, or whatever our condition is, we want to jump to some label, let's say equal. Otherwise, we want to jump to the end label. And then comes the equal. And that is the end of the macro. And then we're going to have the macro if end with 0. And at this point, it's not really going to do anything. Except we're going to have the end label here. Okay, so first we have if and then the instruction where we do the compare. So if statement, and that's what this does. It just takes the argument and runs it. And then we have the then with an E for checking if it's equal, which turns into a jump if equal to this label. Otherwise, it jumps to the end. And then comes the equal, then the code, and then we have if end, which just produces the end label. So I think this is going to work. I hope. Maybe we should do if end just like this, since there's no other signature-like thing there. Alright, can we compile this stuff? So let's see. We run nasm, and we want to create a bin. And we take our input file. And then I guess we need to, no, we don't need to link this. I have an objdom macro. If you do an alias, you can see it's this one. So I have created an alias, which is objdom86, which runs objdump and says that we're going to produce 16-bit code, binary format, for Intel 8086. So you can just take this whole line, type it in like this, and then you can run objdump86 on our output file, which is if dot, no, what is it? Well, it's just if. Okay, so this is the code it produces. We compare AX to 5. We jump if equal to 7. Otherwise, we jump to C. Then comes 7, which runs our code inside of the if statement. And then the C that we're jumping to here is the end label, which is down here at the end. It's not showing. Okay, so it does all that we want, right? Okay, so far so good. But we can improve this, because for one, we don't have any possibility of else. And for else being possible, let's see, we should not jump if it's equal in this case. we should reverse whatever this is. So if we send an E here, we need to turn it into an NE. And there is support for that. We can do -1 instead of just 1. Then it will turn an E into an NE and reverse all the conditional expressions. Alright, so in this case we want to jump to not equal. And we want to have our not equal right here. No, we want to have our equal right here. And then comes this code. And then we need an else, because this is not going to work without an else now. So even if we have an empty else, we still need it. But let's say we move another value into bx and issue another interrupt in this case. Okay, so we need to create the else. And the syntax is just else without any other stuff. So macro else 0. And here we want to have the not equal, like so. But we want to jump, let's see here, yeah, we want to jump to the end here, because first comes this, and this, then we need to jump past this stuff which we are creating here. So it's going to look something like this. And then comes this stuff, and then the end label. So let's see if it works. So we compare AX to 5, we jump if not equal to C, and C contains the else right here. Otherwise we just run the then code, and then we jump to 11, which is the end label down here. So it does exactly what we want. Perfect. So what if we want to nest this? Will that work? We can try. Let's say we have an if statement here. We still move bx into 5. We don't issue an interrupt. Instead we want to have another if statement where we, let's say we test cx for 2. And if that is true, we want to add bx to, else nothing. And then if end. All right. Will it work? What do you think? Let's see. Okay, we get a lot of errors and warnings here. First I misused it. Let's see here. We forgot to put the condition, And when we use test, we usually want to check the 0 flag, so let's add that. Okay, label if nick inconsistently redefined. And same with if end. So it complains that we are defining the labels many times. And that is true, because we are still using this exact label and this exact label. And we can only define a label once, so we need to pick another name for it the second time. So with this construction, we cannot nest the if statements. All right, so what could we do instead? There is a construction inside of NASM, which instead of using a dot as a prefix for the label, we can use a %. And what it does when we use this line of things is it will create a local label, which is local to this macro. So let's replace all of these. And let's see if this works better. It's still complaining. So this is the types of labels that it's automatically generating. But it's complaining that it's not defined. So why is that? Well, this type of construction works perfect when we are only dealing with one macro. But here we have the if statement, we have the then, we have the else, we have a lot of different macros. And each time we define a new macro, this will become a new label. So we can't refer to a label from another macro. So this is not going to work. However, there is a very nifty thing which is called a context stack. So what we can do is, inside of this if statement, we not only do the instruction here, the %1, but we also do push if, let's say. So this is going to create a new context frame and push it onto the context stack. And this allows us to define labels which are local to the current context. So instead of using a %, we do a $. And it's still going to create a temporary label, but it's going to be we're going to be able to refer it from the different macros here. So let's just change all of these. Like so. And by the end here, we do pop, and that will remove the context frame that we created here. And the good thing with this is, when we do the nesting here, that means it's going to push another context, so creating a new context with new labels for that level of nesting. And then it goes back to the first one again when we do the if and. So let's see if this works. Okay, let's see. Context stack is empty, it says. Interesting. If statement. Push if. Maybe we need to do like this. So we want to check if the context is if. And then we want to do this. Maybe that's why it didn't work. Same here. If context, if. Maybe it's and if, right? The same here. Alright, let's see what it says this time. Okay, we got to... we removed all the errors except one here. Line 39. So the then is... Alright, we cannot reverse the C. I don't think there is such a thing as not C. Is that the problem? Think so. So maybe we can wait with a test case, and let's do another compare here for now. Compare CX to 2 instead. So then, let's say not equal here. So if CX is not 2, then do this. Right? No, it's not it. 2.eq, inconsistently redefined. Let's see, what did it say more? Line 13 and 39. So it's this one. But I don't think we actually need this one, do we? Let's remove it. Alright, that's good. Let's see what we produced. So we compare ax to 5, and if it's not equal, we jump to 12. And 12 is down here, and in this case we only put 9 here and int 12. But if it's equal to 5, in that case we move bx5, then we do a compare of cx and 2. We jump if equal to 12, which is the code right here. We add bx2. So let's see. If cx is 2, we jump down here. If it's not 2, then we add 2 and we jump to the end. Yeah, this is pretty much what we wanted, right? So this way we are able to do nested if statements inside of assembly. And we can also do like some error checking if we like. So let's say we forget this if statement right here, but we still have the then. Then we should produce an error, right? So inside of the then here, we can do this if context if, do this, else we can produce an error. Let's say if then else syntax error or something. Which means that if we try to compile this, we get this if then else syntax error, which is a little bit more helpful than just stuff like this alone. Alright, so this is advanced and has macros. If you are interested in this stuff and want more of this, please let me know in the comments. I really hope you liked this episode. Please don't forget to like and subscribe. And thanks for watching. Thanks for today.